Hello, how's it going? So today is March 11th, and this there's this ghost model, basically a model that is hidden called Hunter Alpha on OpenRouter. And basically, there's actually two models that are stealth models. They have a name, but they don't tell you what kind of model it is. And there's a bunch of speculation on Reddit right now that this is DeepSeek-V4, and they're getting a sense of the output of this model from users. And basically, if you look at the model description, it says that it has 1 million context length, and we assume, or there was a lot of leaks saying that DeepSeek-V4 also has 1 million token context length, and this one is 1 trillion parameters. So that looks pretty good. And it looks like it is mostly instruction following and used for OpenClaw. So we also know that DeepSeek-V4 is mostly agentic and coding based model. So this basically fits some of the descriptions of DeepSeek, but we're basically unsure because it is closed. There's also one called Healer Alpha, which has a shorter context length of 262, or basically it's 256K context, or 500,000. And this one basically says that it can do complex multi-step task and a visual. It supports vision and audio inputs. It basically looks like this is one of the smaller models that is Omni, and the other one is a larger model. We can also check by throughput. This is like a 95 tokens per second. And for this one, it is 39 tokens per second. So we can just quickly gauge that this one is probably larger or has more active parameters. So it would be harder to run, and thus it has a slower tokens per second output speed. Just by the size, we're probably estimating the other one is like half the size. So if this one is 1 trillion parameters, that one is probably 500 billion. It doesn't really say on here how many parameters this one is. So it could be just, lower active parameters. All right, so let's go ahead and test Hunter Alpha. I'm just going to quickly ask it some questions and see how it answers. Obviously, the first thing we have to do always is say hello and see how it responds to our introduction here. So the user says hello. So the first thing is we can see the chain of thought. And so we are assuming this is a Chinese model or an open source model, because we can see the chain of thought pretty easily here, where the American models usually hide the chain of thought. On the other hand, if you test, I'm just going to get both of them here. Healer Alpha. So we can just test both at the same time. As you can see, they both have a similar style here. So Healer Alpha is the smaller one. And it looks like they both have a similar style. So what I'm going to do right now is I'm going to go to settings here, go to advanced settings, and we're going to just make sure that the setting for sampling settings are correct. So I have temperature 1. I'm going to set temperature to 0. So it is the most accurate that it can be. And we're going to make sure to apply it to all. So what happens in some of these models is the temperature can make them kind of chaotic, and they won't be able to code well. And since we're trying to see how well they reason and code, we're just going to make sure that their temperature is set to 0. It's the most probable answer that they can have. So now we're going to just quickly test an SVG. Please draw an SVG of a Pelican on a bike. Now this basically tests their creativity and the way they can reason and hold spatial awareness in code. Although this is kind of like a used SVG that's been used quite a bit, so you can see the healer alpha already processed. We're just going to go ahead and see how this looks like. So this is, so for reference, sorry about this. This is Kimi K, no, sorry, this is GLM5 at 4.8 bits I was testing before, so we'll just compare that. So the smaller one didn't do such a good job, honestly. That is not a good job. And so the first one there you saw was GLM5 quantized running locally. And so this one is the healer alpha. It looks like it's a pretty small model based on this response. You can see that the beak is incorrect and there's like artifacts here. So that's interesting. And this one is still processing the response. It's not outputting chain of thought. So what I'm going to do right now is I'm probably just going to stop testing healer alpha because we can see that already it's not a very big model. Probably like 20 billion parameters, maybe, 30, maybe 10. I can't really tell right now, but it's not a very big model at all. And so there we go. All right, so it has a very small description. I just want to read through some of the chain of thought. And so the chain of thought is very short, which is good. And it looks like it is outputting a lot more than the healer version. And again, I think the healer version is very small. It's not like 100 billion. It's probably like a very small model just based on that quick SVG here, but I'm not quite sure. Okay, so this is the output. This is the output of the 1 trillion parameter model. And as you can see, there's quite a big difference. Let me just make sure that I'm not in the way here for you guys. All right, so as we can see, the Pelican does have a beak and everything, but it's missing its legs, and it doesn't look like there's like a chair for the bike. Yeah, so the Pelican is basically missing its legs, but otherwise it's not bad. Now what we're gonna do now is just test another prompt, and I'm gonna put the chat memory to 1 so that it doesn't really remember anything from its prior experiences of us talking to it. So it's not going to be able to remember the last message that we sent it. So right now I'm just going to ask it draw an SVG of a fighter jet F-22 top-down view as detailed as possible. All right, so that's a pretty basic prompt, but I saw that some of these have a bit of issue with drawing this specific prompt because it specifically needs world knowledge of this plane. And just for reference, I'm just going to quickly show you guys what it looks like. So we are looking for some sort of image, top-down view of this kind of plane. As you can see, we're looking for a wing shape that's kind of like a triangle rather than like a normal fighter jet. And we're also looking, the back wings are kind of big for this kind of airplane. So this is what we're looking for. It is kind of a more trickier response or a question that we are asking it, because most planes don't look like this, and this plane will probably trick it a bit. We're going to see what kind of basically world knowledge it has, as well as output. So it looks like this model kind of takes a bit of time responding. Yeah, I'm just going to go ahead and pause myself here for a bit. All right, we're back. It took quite a while, actually. Mostly, I think, because of the servers. Everyone's testing this model. So let's take a look up at the chain of thought here. So again, this is the fighter jet, and I specifically asked for F-22. So let's look at the thought process. So it knows that it's a Raptor, which is correct. It has diamond-shaped wings, which is correct. And it has twin vertical stabilizers, 2 engines, air intakes on the sides. Okay, it has cockpit. Oh, it has a length and wing area. That's interesting. I have no idea if that is accurate or not. 42-degree leading edge sweep. Okay, that might be accurate. So we're just gonna look at the code quickly. Yeah, it's very long code, so it was actually doing something here. And we can also see the view box is 1200 by 800. So that should be quite detailed. Okay. Ooh. Okay, so this is interesting because it is not accurate, but it is very pretty. That is definitely the wrong flag, because F-22 Raptor is American, and the wings are incorrect. And yeah, this is definitely wrong. But this is kind of like a harder thing to get right. I do like the details that it added to the plane itself. It's probably that there's something wrong with the maybe the quantization, maybe there's something wrong with the inference, but as you can see, everything is lining up, and mostly I'm looking into making sure that all the parts are kind of lining up with the model, and they do line up. Even the measurements are good here. The issue is that it just doesn't look like an F-22 Raptor, which should look like this. And so it could be that it doesn't have this in the training data, which is correct. It shouldn't have it. We're just going to go ahead with something simpler now that it should have in its understanding of what a car looks like. So we're going to prompt it for in HTML using any libraries you want. And we're going to ask to make sure that is voxel, making sure that this is a voxel. Okay. All right, so we're just gonna go ahead and do a bit of a waiting game again, because this model is very sought after right now. I guess everybody is benchmarking it. So I'm just going to go ahead and stop it until we get back to it. Now, it is still running, but I just wanted to give you guys a comparison of what the best model so far, or one of the top models so far, looks like. So we're trying to see if it can do something like this. And this is basically Claude Opus 4.6 Max, which is created a detailed modern Formula 1 car. So this is what like one of the better models can output. All right, so it is starting to output the code. And I'm kind of excited to see how it's going to perform. This is a bit of a different test because it is basically testing voxels and three-dimensional rendering rather than just SVG, which is two-dimensional rendering. I wouldn't say one is more complex than the other because I've seen models really fall apart on the SVG stuff, but in other cases they did really good on the voxel stuff. So it could be here or there. We're just looking at it output, and let's just read through some of the thinking that it did. It doesn't think a lot. It basically is going to use HTML, CSS, JavaScript, correct? And it's not always that the output here is okay. Well, it's done. Is it done? Yes, it's done. So I'm just going to go ahead and quickly copy this. I really want to see what it looks like. All right, I'm just going to go here and whoa, hold on. Hold on. Okay. Okay, this isn't bad actually. I really like the reflections. There's only 521 voxels what it said it had. As comparison, let's just bring up, this is Claude Opus, and this one has 2,700 voxels. So, but it does look very similar. It's just very lower, it's lower poly. And again, I do have the temperature at 0. It potentially isn't the right settings for it. It's just we don't know what the right settings are right now for inference. So I'm putting 0 as just whatever the most probable output is. Okay, you know what? It did a really good job of this. I do want to just try it out one time with the same prompt, but I'm just going to go ahead and put the temperature to 1 and see if it does better. So let me just go ahead and do that. All right, so we're back. I retested the same prompt, but temperature of 1 to make sure that it is a bit more verbose, because we did get a good output there. Where's my HTML viewer? So this is the one beforehand, and now this was 591 before. I'm just gonna go ahead. Oh, 1,000. Whoa, 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 whoa. Hold on, hold on. Hold on there. Hold on. Hold on. This is good. Okay. Right click to pan. Okay. 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 Okay, so let's just quickly I don't know which one's better, but this is very good. This is very good. Okay. Okay, I'm a bit more hyped now. This is very good because it means that it kept its own logic and reasoning through temperature 1, which is really good. I wonder if we could like make it output more. The only thing I want to be careful of with OpenRouter is I've never had really good experience with all these like test models, and I usually like test it like JLM5 and other models on here, and it doesn't really do a very good job. And then when I run it locally, and once the settings get fixed and everything, then the model like starts to shine a lot, and really the outputs start to become much better. So if this is like not the right settings, but we're getting like really good output here, we potentially have a winner here. Okay, I'm very curious. I'm just gonna throw in one more test. This is gonna be like a very difficult test, and I'm just gonna see again. This is gonna be SVG related, not voxels, because potentially that this test has been, seen already online, and I have a custom one here that we're going to test. Let me just find it. All right, so I'm going to paste in this prompt and send it. And basically, I want to design a flat 2D view of this laboratory, and it's going to have some specific parts in it. There's going to be specifically rotating gears in clockwise and counterclockwise direction. And we're going to make sure that there's a specific gear ratio, and we locked it to a certain view box. So locking to a certain view box is a bit trickier for models because they have to, reason in that view box rather than like make up their own, and they should be a bit trickier. So this is going to be like quite a tricky prompt for it to try to overcome. And now that we have one of the tests with the car and seeing how it really rendered the lighting really well, I'm kind of curious to see if this custom prompt is something that it can do. Now, I have a bunch of custom prompts that I test these models with, but I try not to leak them online because that way it becomes part of the data set, and once they get trained on that data set on Reddit or somewhere else, we basically cannot test the model anymore. So this is like one of them, but I'll probably start testing this specific prompt with other models just to verify how they work. And just so you know, once a model gets quantized, if it doesn't get quantized very well, the harder prompts will kind of like make it explode. So one of the actual stories while we wait is I was testing Qwen 3.5 with this kind of prompt, and the BF16 version did really good job, whereas even the Q8 versions kind of gave me garbage. So it's really like good to just check what kind of quant and if you got the right settings down, just to check like if you got a usable model there, or you're just gonna get garbage. And yeah, I was testing some of these models online with some of the harder prompts, and what happens is sometimes they kind of lose their mind. Not specifically on this prompt. This is, I think, still one of the easier versions, but the harder ones, they kind of like explode. They literally give you garbage output, and some of the better models like GLM5 will kind of get close to your prompt, but they'll try to like part it out, which is kind of interesting. Like if you ask for one piece design of like this complex shape, you'll see that some of the smarter models will understand that they cannot output that shape in one piece. And what they'll do is they'll cheat. They'll say, okay, I cannot do it in one piece because it's too complex. I will do it in multiple pieces and then kind of stitch it together afterwards. And you'll be able to see that in the code because you'll see like left side, right side, middle side, and they try to like stitch together after they reason out the dimensions of each side. And I feel like that's also valid in terms of problem solving, especially if they cannot, output the code fully. Some of the larger models like GPT-4, 5.4, and Gemini do a really good job in some of these benchmarks on OpenRouter beforehand, but they don't really do a good job afterwards. They become lazy or so on. With the Chinese models, I had kind of the opposite experience, and it looks like it timed out. So what I'm going to do now is I think I'm just going to, because I'm rambling at this point, I'm going to go ahead and pause it, and then we'll get back when we get the output. All right, we're back. It's kind of painful right now because I just have to wait so long to even get a response just because there's so much traffic right now. All right, it looks like it's outputting 800 by 800, which is, I don't think that's what we want. Yeah, we did want 800 by 800. That is correct. So it's sticking to our instructions here. I'm just looking at the output at this point. That's a lot of code. Okay, it's done. Okay, let's try to look at it. This is an SVG, so we can just go to the SVG viewer here, and we're gonna go ahead and replace that. Oh no. Okay, so this is so sad. This is like I waited so long, and I was expecting. This is what basically happens to these models with the gears. I don't know if this model is like quantized or something, but this is what usually happens when you like quantize a model, and it doesn't get like the precision of the spatial awareness of this stuff. So it's not, I don't really think that this model is potentially this bad. But it's definitely like this output is worse than Quen 3.5 397B. And what's supposed to happen is we're supposed to get a table, we're supposed to get like two interlocking gears, and they're supposed to spin. But as you can see, they have the wrong axis as to where they're actually spinning. All right, so I think that is going to be all the testing that I do for this model. I don't necessarily know if this is this bad of a model. Just take it with a grain of salt for all of these tests on OpenRouter, because the inference settings are like one of the most important things to get right. Two, we don't know if this is already quantized just as a preview, and that they don't like specifically have this at full weights here. And yeah, if I go to models, I don't think this is at full weights. I don't think it actually shows me. No. Yeah, it doesn't show anything regarding weights and then it just says that it's good for OpenClaw. Right now, I also did have issues with GLAM 5 when it was on OpenRouter, so just take everything with a grain of salt. And this is just a really good preview of what the model base can do. It could potentially get better from here in later iterations of this model, and they're probably still testing and fine-tuning this. So thank you again for watching this silly video of me testing DeepSeek-V4, but we don't know what it is. Hunter Alpha, and yeah, hopefully you guys enjoyed it, and have a good rest of your day, and see you in the next one.